start lesson 2, which is going to discuss relations. The things that you're going to learn in this chapter are that how relations can be written as tables and what relations are. And also relations written in the form of graphs. Review some of the vocabulary regarding graphs so that you guys are your memories are refreshed on the different parts of a coordinate plane. Of course, 0 is your origin. This first quadrant right here is quadrant 1, and it's written with Roman numerals. The second quadrant is next to it on the left. So it goes counterclockwise. And this is quadrant 4. This is your x-axis. This is your y-axis. And this is a coordinate pair. Now it's asking to identify the x-coordinate in the point -5, -7. Your x always comes first, as you guys already know. So the -5 is your x-coordinate. Once again, we're going to review what a relation is and the different components of a relation. Relations are a set of ordered pairs. A set of ordered pairs. And they can be represented in a table, and they can be represented as a graph. So we're going to be doing both of those, table, graph. Okay? The x is going to be your domain. This is your domain. And see, it's ABC order as well, so that makes it easy to remember. Range is your y. So domain range is x, y. In example 1, they talk about relations, and they're expressed in brackets right here. When they ask you to put it in a table and state the domain and range, you're going to put it in a table, and your x coordinates will be your domain, your y coordinates will be your range, and you will list those, and I'll show you in a minute. This is your domain, and these are your range. Then they show, as they asked in the example, they show as you can see here, the graph is, the ordered pairs are shown on the graph. So these ordered pairs are shown as coordinate points on the graph. And then as they ask, they want you to write the domain in brackets, which are all the x values, and the range in brackets, all the y values. In example 2, they have a problem that says that it costs $3 per hour to park at the Wildwood Amusement Park. They wanted to make a table of ordered pairs in which the x-coordinate represents the hours and the y-coordinate represents the total cost for 3, 4, 5, and 6 hours. So you're going to put 3, 4, 5, and 6 as the x-coordinate because those are the hours. So they go in this part of the graph, the table, and then you're going to figure out at a rate of $3 per hour how much the y-coordinate will turn out to be. So as we learned earlier, we could put that the cost is equal to the rate, $3 per hour, times the number of hours. Once you have done the math, 3 times 3 is 9. 3 times 4 is 12, etc., they want you to put it in a graph. So here you can see 3 is your x-coordinate, 9 is your y-coordinate, 4, 12, 5, 15, and 6, 18. On page 279, example 2, actually it's on the got it portion at the bottom. It says a movie rental store charges $3.95 per movie rental. Make a table of ordered pairs in which the x-coordinate represents the number of movies rented and the y-coordinate represents the total cost for 1, 2, 3, or 4 movies. So to make the table, they ask for it, the x-coordinates to be the number of movies rented and the cost for 1, 2, 3, or 4 movies. So number of movies rented is going to be your x-coordinate. And then the cost of the movies. Okay, so if we do as they ask, and we try 1 movie, 2 movie, 3, and 4 movies at $3.95 each, our equation is going to be cost equals $3.95 per movie times the number of movies. Okay? So 1 times $3.95 is $3.95. 2 times $3.95 is $7.90. 3 is $11.85. And 4 is $15.80. In part C, they asked to graph the ordered pairs. So for 1 movie, it's almost $4. For 2 movies, it's almost $8. For 3 movies, it's almost $12. And for 4 movies, it's almost $16. And once again, you can see the linear relationship that this relation has in these coordinate pairs. If they ask to list the domain in range, you would, in brackets, put the x-coordinates as your domain, that's your domain, and your range would be $3.95, $7.90, $11.85, and $15.80.